Section 7.5 are more trig equations. We are going to follow the same type of problems that we did in 7.4. However, we're just going to use some of the identities. So if we have sine squared or cosine squared in the same equation, then one of them needs to change using the Pythagorean identity. And you know which one to use based off the linear term. So this linear term right here, sine, determines which trig function we're going to have the equation in terms of. So the first thing I'm going to do here is change cosine squared, since it needs to be in terms of sine, into 1 minus sine squared using my Pythagorean identity. So we have sine squared x minus sine x is now equal to 1 minus sine squared x. I'm going to set this equal to 0. So that means when I add 2 sine squared, I'm actually going to have 2 over here, minus sine x minus 1. And I'm going to factor. So off to the side, I can factor. If I let u equal to sine x, I have 2u squared minus u minus 1 equal to 0. So what multiplies to give you negative 2, that adds to give you negative 1, negative 2, and 1. So then I group those, and I take out my GCF for each one. So my final two factors are going to be 2u plus 1 and u minus 1, which means that we have 2 sine plus 1 and sine 2 sine x, plus 1 and sine x minus 1. So if I set each of those equal to 0 and I solve, over here I get sine x, and then I would subtract 1 and divide by 2, so equals to negative 1/2. And on the right side I'd have sine x, which is equal to 1. These are both values on the unit circle. For over here for sine of negative 1, it's going to be, or negative 1/2, it's going to be in my bottom two quadrants because it's negative. My reference angle for sine of 1/2 is pi over 6, so that means in quadrant 3 I have 7 pi over 6, and in quadrant 4 I have 11 pi over 6. And then over on the right, sine x is only equal to 1 at one angle of pi over 2. Okay, so in this example, my linear term is sine again, so we're going to set the equation equal in terms of sine. So cosine squared equals 1 minus sine squared of x plus sine x equal to 1. So then I'm going to set it equal to 0 and add like terms, so I get 1 minus sine squared x plus sine x minus 1. So my 1's subtract, and I have negative sine squared x plus sine x. So now I could take a GCF out of negative sine x, and then I'm left with sine x minus 1. So if I have negative sine x equal to 0, then we're just trying to find the value, if I divide it by negative 1, of sine x of 0. And that value is at 0 and pi. And then on the right, I'm trying to have sine x equal to 1, and just like the problem we did before, that is at pi over 2. And we are finished this problem. All right, so if we are given a value that's the double angle formula, we're going to use it and change sine of 2x, or whether it's cosine, whichever one. So my example over here, I have a double angle with sine. So I'm going to say 3 sine theta is equal to the double angle, which is 2 sine theta cosine theta. I'm going to set it equal to 0. And now I can take a GCF out of sine theta. So sine theta comes out, and I'm left with 3 minus 2 cosine of theta. So my first trig equation is sine theta equal to 0, and sine is 0 at 0 and at pi. And then over here, I have 3 minus 2 cosine of theta equal to 0. So if I subtract 3 and divide by 2, then I get cosine of negative 3 over negative 2, so 3 halves. And we can't have a value of cosine that is greater than 1, and this is 1.5, so we have no solution. If you went further and put this in your calculator would say you have a domain error, which means no solution. So again, I have a double angle with a sine. So I have 2 sine x cosine x equal to cosine x. So I'm going to subtract cosine x so I can set it equal to 0. So my GCF in this case is cosine x, and I'm left with 2 sine x minus 1. Cosine is 0 at pi over 2 and at 3 pi over 2. And then we have 2 sine x minus 1. So then we have sine of x, we add 1, divide by 2, so we have 1/2. And so that's positive, so sine is positive 1/2 at pi over 6 and at 5 pi over 6. So all these values so far have been on the unit circle. Okay, so if we have a double angle with cosine, we have a couple options. So if the other term that is there, other than the double angle term, is sine, you're going to use the double angle formula in terms of sine. If the other one is cosine, you're going to change it and use the double angle formula that's in terms of cosine. So the term that is single, the single angle, that linear term right there, that is going to be the one that dictates which one of these over here that you substituted in. So 3 stays on the outside, and since it's in terms of sine, I'm going to use 1 minus 2 sine squared of theta. And so, it's in terms of x. And so then I'm just going to add 7 sine of x, and then I'm just going to subtract 5 all in one step because I know I'm going to have to set it equal to 0. So I'm going to distribute this 3, and I get 3 minus 6 sine squared x plus 7 sine of x minus 5. And I can add that 3 and that negative 5. So I have negative 6 sine squared x plus 7 sine x minus 2. So now it's in a quadratic form and I can factor this. So what multiplies to give you positive 12, that adds to give you 7, 3 and 4. So I have negative 6u squared plus 3u plus 4u minus 2. I can factor out a negative 2. I'm sorry, a negative 3u. I'm left with 2u plus 1. And then I can factor out, oh, nope, 2u minus 1. Sorry, I forgot that negative. And then I can factor out a 2, and I'm left with 2u minus 1. So my two factors are negative 3u plus 2 and 2u minus 1. So we're going to go back in and substitute in sign for those values. And I get negative 2 sine x plus 1 and 3 sine x minus 2 equal to 0. So on this left side over here, I'm going to set it equal to 0 and then subtract 1, divide by 2. So then I get sine of x equals to 1/2, which we've done before, and we know that that's at pi over 6 and 5 pi over 6. Both are in quadrants 1 and 2 since it's a positive value. And then over here, I'm going to have sine x of 2/3. This is not on the unit circle, so my reference angle is going to be sine inverse of 2/3. And when I plug this into my calculator, I get 0.730. Now, 2/3 is positive, so once again I need quadrants 1 and 2, which means that my reference angle in this case is one of my solutions. And then my other angle x, I am going to have pi and I'm going to subtract my reference angle to be in quadrant 2. And I have 2.412. Okay, so I have another double angle, and it's going to we're going to keep it in terms of cosine because right here this single term is cosine. So we have 3 times 2 cosine squared x minus 1 plus cosine x, and then I can subtract that 2, distribute the 3, and add like terms. I get 6 cosine squared x plus cosine x minus 5. And after I factor this one, I end up getting 6 cosine x minus 5 times cosine x plus 1. So on my left, I'm going to have cosine x is equal to 5 over 6. This is positive cosine, so it's going to be in quadrant 1 and 4. When I find the reference angle in my calculator, I get 0.586, and I need this one since I need quadrant 1. And to be in quadrant 4, I'm going to subtract that value from 2 pi. And when I do that, I get 5.697. And then over here for cosine x plus 1, I'm going to have cosine x equals -1. And cosine is -1 at pi. Okay, last problem. Sine is my single term, so that double angle I'm going to write in terms of sine. So I'm going to have sine x equal to 1 minus 2 sine squared x. I'm going to subtract it to the other side, which gives me I'm going to add 2 sine squared x, and then I have plus sine x, and then minus 1. After I factor, I'm going to have 2 sine x minus 1 and 2 sine x plus 1. So on the left, we have sine of x is equal to 1/2, and sine is 1/2 of pi over 6, and 5 pi over 6 from my unit circle. And then I have sine x. Oh, there's a mistake here. It shouldn't be 2. It should just be sine x. Sorry about that. So I have sine x is equal to -1. And sine is -1 at 3 pi over 2. So with these equations, you are looking for identities, double angles. We're only using the sine and cosine double angle. We're not using the one that has cosine in terms of sine and cosine. That's not going to help us. So practice and look for the things that you need to look for. Know your unit circle, and that's how you will be successful in solving trig equations.